Good day, grade 10s. This is now part 2 on our electrostatics exam revision. So we're gonna do now question 11, 10 marks. Similar questions to the previous video that we did. So here, let's read the statement. The statement says, two identical metal spheres A and B on an insulated surface carry charges of negative 2,8 times 10 minus 6 coulombs and positive 4,5 times 10 minus 6 coulombs respectively. The spheres are brought in contact with each other. Here you see now the diagram, but there is a mistake here. If you see here, they say it is negative 2 times 10 minus 6, but on the diagram we see negative 2,8 times 10 minus 9. This one was 4,5 times 10 minus 6 coulombs, but on the diagram is 4,5 times 10 minus 9. So we are not going to follow this one. We are going to follow these magnitudes that are shown on the diagram. So now let's read first question, which is 11.1. 11.1 says, it is observed that the spheres move apart after contact. Briefly explain this observation. So now they are brought into contact. We know from the previous video, we said when two unlike charges, the other one is negative, the other one is positive, come into contact, they attract each other, come into contact. What's happening at that time? They are sharing electrons. In this case, A is negative, so A will share electrons to B. And then when they have shared enough or equal amount of electrons, they will be equal amount of charges. Then after that, we know they will separate or they will repel each other. That's what they are asking here. They said, briefly explain this observation. Why they move apart. Why they move apart after sharing. So you look at the number of marks is 3 marks. That means there are 3 sentences you must write in explaining your answer as to what is happening after contact. So 11.1 we said, what's going to happen first? During contact, sphere A will transfer electrons to sphere B. Then secondly we say they will, you can say they will share electrons until they have equal amount of charge. Equal amount of charge. Then due to the equal amount of charge, they will repel each other. Because if they got the same amount of charge now, they repel each other. So there are keywords there. The first one, by stating that A transfers electrons to B, that's 1 mark. by stating that they will have equal amount of charge. You get another mark by stating that they will repel each other due to the equal amount of charge. You get a third mark. So that's how you must answer 11.1. Now 11.2 says now calculate the new charge on each sphere after they move apart. Now we want new charge, so let's quickly look at this. So we have here sphere A. Let me draw sphere A. So I'm gonna draw sphere A here. So this is sphere A. Then let me draw sphere B. So that is sphere B. So we said, yeah, sphere A was negative 2,8. Sphere A is negative 2,8 times 10 to the power negative 9 coulombs. Then sphere B is positive 4.5. Is positive 4.5 times 10 to the power negative 9 coulombs. That is sphere B. Remember, this is happening initially. So that's initial. Then we know that they will come into contact. Then they will come into contact with each other. So now they are in contact. They are in contact. Okay, let me do this correctly. Now they are in contact with each other. Okay, that is sphere B, that is sphere A, even though they are not the same in size. Alright, this is A, that is B. Which side will electrons move? Electrons will move from A to B. Electrons will move this way, from A to B. So after they shed electrons, A will move this way, B will move that way. This is A, that is B. So we want to know now what is going to be, calculate a new charge on each sphere after they move apart. What will be the Q new for A? What will be the Q new for B? We want to get this magnitude. Now we know how we do this. We use our formula. We use our formula that says Q new is equals to QA plus QB divided by 2. So what is QA? Is minus 2,8 times 10 power negative 9. What is B? Positive 4,5 times 10 minus 9 coulombs all over 2. So punch on your calculator. So open a bracket, negative 2,8 exponent negative 9, close the bracket, plus open a bracket 4,5 exponent negative 9, close the bracket, denominator is 2. The answer is 8,5 times 10 to the power negative 10. 8,5 times 10 to the power negative 10 coulomb. So now we have the answer for the Q nu. Now Q nu, we said it's for A. Q nu for A is 8,5 times 10 to the power negative 10. Yeah, times 10 power negative 10 coulombs. And also for B is going to be the same, 8,5 times 10 to the power negative 10 coulomb. That is Q nu. So we're done with question 11.2. Now let's look at the following question, and the last question is 11.3. Calculate the number of electrons transferred. Number of electrons transferred from one sphere to the other during contact. So which sphere is transferring electrons here? Is the negative one, which is sphere A. So we know this is Q initial for A, this is Q nu for A. So we want to know the difference first from initial to nu. We want to know this one, the Q transfer, which is Q final minus Q initial for A. We are focusing at A because of it is the charge that is transferring electrons to B, because of it is negative. So let's calculate first the number of charge, the amount of charge that was transferred. So 11.3, we say Q transferred is equals to Q final or Q nu minus Q initial. We are focusing at charge A. Then let's substitute the final charge. You said is 8,5 times 10 minus 10 minus the initial charge, it was negative 2,8 times 10 minus 9. So yeah, initially it was negative 2,8 times 10 minus 9, finally is 8,5 times 10 minus 10. So let's take the calculator now and punch this and check. So we have 8,5 exponent negative 10. Close the bracket, subtract negative 2,8 exponent negative 9. Close bracket. The answer is 3,65 times 10 to the power negative 9. 3,65 times 10 to the power negative 9 coulomb. So this is Q transferred for A. So now we've find the number of transferred electrons. The number of transferred electrons is equals to that Q transferred divided by QE, the quantization of charge. So we want to find now the number of transferred electrons. Q transferred, we said, is 3,65 65 times 10 to the power negative 9. 3,65 times 10 to the power negative 9 coulomb. So this is Q transferred for A. So now we've find the number of transferred electrons. The number of transferred electrons is equals to that Q transferred divided by QE, the quantization of charge. So we want to find now the number of transferred electrons. Q transferred, we said, is 3,65 times 10 to the power negative 9. the quantization of charge is 1,6 times 10 to the power negative 19. Now, if this 3,65 was negative, we were going to divide by negative 1,6. But because of it is positive, then we divide by positive 1,6. You must be careful there. Take the calculator. That 3,65 times 10 minus 9, just divide it by 1,6 exponent negative 19. The answer is 2,28. Take two decimals, 2,28 times 10 to the power 10. 2,28 times 10 to the power 10 electrons. This is a number of electrons that were transferred. So it's a similar question that like the previous one. So I think now we are at least clear about the electrostatics and how to answer the questions on electrostatics. So yeah, this is the end of our video. I'll try to find another one and then I'll do it if I get one.